The surface of the earth is unstable in nature. The instability of the earth's surface is mostly caused due to the internal or endogenetic processes. Earthquakes are one such factor which induces instability in the earth's crust. Earthquakes belong to the endogenetic process whose origin is located in the interior of the earth. Earthquake as an endogenetic activity belongs to a process called as catastrophism, which is a sudden and violent process, the impact of which is immediately visible on the earth's surface. It is considered as a natural disaster. Some of you must have experienced and heard about the shaking of the earth. The question here is why the earth's surface experiences shaking. What happens during the shaking of the earth's surface? To understand the characteristics of the seismic waves, to classify and analyze different types of earthquakes, to analyze the causes of earthquakes. Seismology is the science that studies earthquakes. Seismological studies provide perhaps the most reliable evidence about the internal structure of the earth. An earthquake is a vibration in the form of seismic waves that are produced by sudden release of energy. An earthquake, in simple words, is the shaking of the earth or tremors experienced in the parts of the earth crust. Earthquakes are the tremors experienced in the earth's crust due to the passage of seismic waves. Earthquakes are the vibrations of the earth caused due to the ruptures and the sudden movements of the rocks. Earthquake is a form of energy of wave motions transmitted through the surface layers of the earth. Earthquake is also defined as a shock or series of shocks due to the sudden movement of the crustal rocks. When an earthquake occurs, energy is released, and this released of energy is carried in different directions in the form of seismic waves that produce shocks or vibrations in the rocks. The point of origin of the earthquake, or where energy is released, is called as focus of an earthquake, which is located inside the earth. The depth of the focus varies from one place to another. It is also called as hypocenter. The energy released during the earthquake is transmitted to the surface of the earth focus in the form of seismic waves. The point that is located directly above the focus on the earth's surface is called as epicenter. The earthquake shock is first felt at the epicenter, and therefore the intensity is highest. Maximum damage due to the earthquake is experienced around the epicenter. The waves generated by the earthquake are recorded by an instrument called as seismograph. Seismograph records the seismic waves in the form of foreshock, main shock, and aftershocks. The energy released during an earthquake will be transmitted to the surface of the earth from the focus of the earthquake in the form of waves which are called as seismic waves. Three types of waves are produced during an earthquake. They are as follows: primary waves or P waves, secondary waves or S waves, surface waves or L waves. P waves. P waves moves faster and are first to arrive at the surface. Therefore, they are called as primary waves. Primary waves are also called as compressional or dilation waves. The energy particles in P waves travel to and fro in the direction of seismic wave propagation. They are similar to the sound waves. Primary waves can pass through any medium, that is, they can pass through solid, liquid and gaseous material. Primary waves are the fastest as compared to secondary and surface waves. The velocity of P waves depends on the density of the rocks. While traveling through the liquid medium, their velocity decreases. The velocity of primary waves varies between 8 to 13 kilometers per second depending upon the medium through which they travel. S waves. S waves are called as secondary waves because they are recorded in the seismograph a little later than the P waves. S waves are also called as transverse or shear waves. S waves or the secondary waves are similar to the light waves. In S waves, the energy particles move up and down perpendicular to the direction of the seismic wave propagation. Unlike P waves, S waves cannot pass through all the type of mediums. S waves can penetrate or travel only in solid medium. The velocity of S waves depends upon the density and rigidity of the medium through which they pass through. The path of the S waves through the interior of the earth is concave due to their decreasing velocity. L waves. Surface waves differ from P and S waves in the context that they do not travel through the body of the earth. L waves travel through the surface of the earth only and therefore called as surface waves. Since L waves are confined to the surface of the earth, the long waves follow a convex path. They fade out below certain depth. They can pass through both land and water, or they can travel through solid and liquid medium. The velocity of these waves is 3 to 4 kilometers per second and hence they are recorded last in the seismograph. L waves arrives a short while after the arrival of P and S waves because of the greater complexity of the path through the crustal layers. Seismic waves are recorded in the seismographs located at distant places or far off location. However, there are certain locations or the specific areas where earthquake waves are not recorded. Such areas or zones are called as shadow zone. The study of various seismic waves reveals that for each earthquake there exist altogether different shadow zone. As seen from the figure, it is observed that at any distance between 105 degrees from the epicenter recorded the arrival of both P and S waves. However, the seismographs located beyond 145 degrees from the epicenter recorded the arrival of P waves only. Thus, a zone between 105 and 145 degrees from the epicenter is identified as shadow zone for both P and S waves. The entire zone beyond 105 degrees does not receive S waves. The P waves fail to reach the area due to the deflection, whereas S waves are absorbed by the interior of the earth. Earthquakes are classified by various scholars based on depth of the focus, second, human casualties, and third, the causative factors. Based on the depth of focus, Gutenberg has divided the world's seismic centers into three types. One, shallow or moderate earthquakes, in which the depth of the focus located at the depth from the ground surface to 70 kilometers. They are generally called as shallow focus earthquakes. Intermediate earthquakes with seismic focus located at the depth of 70 to 300 kilometers. Deep focus earthquakes are those in which seismic focus is located at the depth between 300 to 700 kilometers. Earthquakes are classified into three types on the basis of their impact in terms of human casualties, as moderately hazardous earthquakes are those in which the human deaths caused by the severe earthquakes are below 50,000 mark. Example, Chile earthquake of 1939, North Iranian earthquake of 1990. Highly hazardous earthquakes are those earthquakes causing human deaths ranging between 51,000 and 1 lakh. For example, Bhuj, Gujarat earthquake of 2001. Most hazardous earthquakes are those in which human casualties is above 1 lakh mark. For example, in 1923 in Tokyo in Japan, 1,63,000 deaths. Based on the causative factors, earthquakes can be classified as natural earthquakes and artificial or man-induced earthquakes. Natural earthquakes are those which are caused by natural processes, that is due to endogenetic forces. These type of earthquakes include volcanic earthquakes, tectonic earthquakes, that is the earthquakes caused due to faulting, isostatic earthquakes caused due to isostatic imbalance, plutonic earthquakes, that is earthquakes which occur at great depths. Artificial or anthropogenic earthquakes are caused by human activities such as pumping of underground fluids, deep mining, then construction of reservoirs and blasting of rocks. The major causative factors for the occurrence of the earthquakes, natural only, but in the recent times human interference with the nature is also emerging as the causes of the earthquake. Earthquakes are caused mainly due to the disequilibrium in any part of the earth crust. A number of causes are assigned to cause disequilibrium of the earth's crust. The natural causes of the earthquakes are volcanicity, folding and faulting, plate tectonics, isostatic adjustment. Volcanic activity is considered to be one of the major causes of earthquake. In fact, volcanicity and seismic events are so closely related to each other that they become cause and effect of each other. In other words, each volcanic eruption is followed by earthquakes, and many of the severe earthquakes cause volcanic eruption. In fact, earthquakes sometimes are the major precursor events of possible volcanic eruption in immediate future in any region. The explosive violent gases during the process of volcanic eruption try to escape upward, and hence they push the crustal surface upwards from below with great force causing severe tremors of high magnitude. Such earthquakes occur either simultaneously with volcanic eruption or more commonly the period preceding the eruption. The magnitude of the earthquake depends on the intensity of volcanic eruption. Their intensity, however, may be quite high near the volcano. The violent eruption of Krakatoa volcano between Sumatra and Java Islands caused such a severe earthquake that the impact was experienced at Cape Horn in Chile, located in South America, 1008 kilometers away. Fracture or rupture in the rocks and displacement of the rock strata on the either side of the fault plane relative to each other is called as faulting. Faulting caused due to the tensional forces as well as compressional forces acting on the rocks of the earth crust. In case of faulting, the rocks either gets displaced or dislocated horizontally or vertically. Sudden dislocation or maladjustment of the rocks triggers earthquakes. The 1950 earthquake of Assam was believed to have been caused due to the dislocation of crustal rocks caused by crustal fracture. Bhuj earthquake in Gujarat in 2001 is also caused mainly by faulting. The San Andreas Fault of California in USA is a typical example which leads to earthquakes in 1906. The occurrence of severe earthquake of San Francisco, USA in 1906 led H.F. Reed to advance elastic rebound theory. Elastic rebound theory explains mode of earthquake caused by fractures and faulting in the earth's crust. During this process of breaking and dislocation of the rocks, crustal surface is disturbed due to the release of energy leading to earthquakes. Plate tectonics theory has been considered as the most plausible explanation of the causes of earthquake. According to the theory of plate tectonics, the plate boundaries are the primary location of the earthquakes and volcanic activity. According to the theory of plate tectonics, the Earth's crust is made up of few major and numerous minor plates. These plates are composed of either the continental crust or oceanic crust or both. These plates are continuously in motion to each other due to the convection current generated in the mantle. Earthquakes of varying intensities are caused along the plate boundaries. Virtually all seismicity is localized around plate margins. There are three types of plate boundaries: convergent plate boundary, divergent plate boundary, and neutral or conservative plate boundary. In divergent plate boundary, plate motion is in opposite direction from the mid-oceanic ridges. Shallow focus earthquakes, in which the depth of the focus varies between 25 to 35 kilometers, are caused along the convergent plate boundaries, that is, along the mid-oceanic ridges. The ridges are commonly offset by large faults that are also sites of shallow focus earthquakes. For example, the earthquakes occurring along the mid-oceanic ridge in the Atlantic Ocean and East Pacific ridge in the Pacific Ocean. Along the conservative plate margins, two plates slide past against each other. Transform faults are associated with these plate boundaries. When two plates move parallel to each other along the transform plots, Usually, there is no volcanic eruption along the transform faults, but the potential for the earthquake is more. Occurrence of earthquakes with severe intensities is common along the transform faults. The eastern boundary of the Pacific plate is a long transform fault system. California's San Andreas Fault is known for many faults, marking the junction between Pacific and American plates. Although most of the world's seismicity occurs along the plate boundaries, the interior of the continents also experience infrequent and scattered shallow focus earthquakes. The zone of earthquakes in East Africa, Western USA and Peninsular India are most striking. An intraplate earthquake occurred in Latur, Maharashtra in 1993, in which 80 villages were shaken and over 11,000 people died. This area was not known to have earthquakes of comparable size in the historical times. Although these continental intraplate earthquakes may be large, they are infrequent. In terms of total energy release by seismicity each year, they account only for 0.5%. Isostasy is the state of balance between elevated areas on the Earth's surface like mountains and low-lying areas like plains and ocean floor on the rotating Earth. The Earth is unstable as the endogenetic and exogenetic forces slowly and continuously disturb the isostatic balance. But the nature always tries to restore the isostatic balance. For example, a newly formed mountain over a period is subjected to weathering and erosion or denudation, leading to unloading of the material. There is continuous lowering of the height of the mountains. On the other hand, eroded sediments are loaded in the plains and ocean floor. In this process, the mountainous areas gradually become lighter, ocean floor becomes heavier. The base of the crust, the pressure exerted by the loaded column increased. The loaded column therefore sinks while the unloaded column rises. By this process, the isostatic balance is restored. During this process, movement of magma is towards the Earth's surface, that is towards unloaded column, that is mountains. Earthquakes are natural disasters which are caused by the endogenetic forces coming from within the Earth. Human over-interference with the nature is also one of the causes of the occurrence of the earthquakes in the recent times. Anthropogenic earthquakes are caused by human activities like large-scale pumping of underground water, mineral oil extraction, deep underground mining, blasting of rocks, nuclear exposure, construction of dams and reservoirs. The earthquakes caused by the hydrostatic pressure of the reservoir are called as reservoir-induced seismicity. Earthquake is an endogenetic process and is considered as a natural disaster. The vibrations or the shaking in the Earth's crust due to the passage of seismic waves is experienced as earthquakes, which is located within the Earth's surface. Epicenter is the point on the surface which is located vertically above the focus on the Earth's surface. Experiences maximum damage. The causes of the earthquakes are mostly natural, but in the recent times, man-made factors are also emerging as causative factors in the seismic event.